In this video, I'm going to walk you through lesson 2 of unit C1. Okay, so we were talking a little bit about sea level rise in lesson 1 and the anchoring phenomenon routine. And now we're going to analyze some data on sea level. So we're going to go ahead and open this up. This is a handout. You'll provide one for each student. And you can see it's a little, so it's going to take a little time for students to figure out this graph because there's actually two y-axes. And so this one is sea level or volume if the ice compared to present. So your zero line is your baseline. This is present. And so if the line goes above, that is more, and the blue is temperature difference from present. Oh, that's going to be on this scale. So look at the orange one, global sea level relative to present. And so the sea level was lower and higher and lower and higher, but present day is right here. So the sea level is as high as it's pretty much ever been. And then if you look at the volume of ice in North America, if it melted, so if all that ice melted, this is where the sea level rise would go up to. And so what students are going to look for are patterns, and really what they're going to figure out is, look at when this goes up, that goes up, and the volume of ice goes down. So as temperature goes up, the sea level rise goes up, and the ice level melts. So a little hard to understand, but just the beginning of kind of interpreting the data on this and looking for patterns. Down below, you're going to see this timeline, and it really just kind of provides a scale. If this is present, the last ice age was here, and first modern humans were here. So this is just kind of giving a relative scale of what this graph is showing. This is like barely a blip on this scale of time. Okay, so once we look at these handouts, we're going to answer some questions in our notebooks, and we're going to analyze that data. What patterns do you notice? And we're going to actually talk about this a little bit. We're also going to examine recent ice melt and sea level with two videos. So one is showing the Arctic ice, and the other one is showing Greenland, and the other one is Antarctica in the second video. It's a simulation, and it basically shows how the ice is melting over time. And this is using real data. We consider then how data is being collected. Like, how do we know this? I mean, we only have been collecting data for so long, but how do we know? So we have some questions we're going to answer in our notebook about, like, how is the data being collected? What types of data can be collected with this method? And then they're going to talk about with their group. These are the three different articles that they will read, and it's going to be jigsawed. So geologic data is about looking at the rocks and any evidence we find in rocks. Ice cores are, taking a core of ice out and having scientists study what's at each level in the ice core. And then clues from humanity are basically how we have evidence of past cultures with writings on the wall or petroglyphs or, that show clues that things have changed over time, ice ages to non-ice ages. Anyways. We then are going to use the Chalk Talk format. Now, the Chalk Talk format is basically giving protocol for students to talk about an article. So here are the questions they're going to answer, A, B, and C, on the poster. And then once you have a certain amount of time that's passed, you're going to instruct them to move to the poster on your side of the room. So you'll have each poster topic on one side, and then you can duplicate that on the other side of your room. And so they'll go through all three posters. When they arrive at the next poster, if any questions are unanswered, they will try to answer them, or they can expand or reply to any of the group's answers that are already provided on there. So they're building on to other students' thinking. Okay, and then when we do that, we're going to be talking about, we're going to look at data from Earth's orbit, Earth's atmosphere, and then a year without summer. This is actually about a volcano, and the ash covered the sun, and so it was a very, very cold summer because of volcanic ash. After we complete the Chalk Talk posters, we're going to do a gallery walk, and we're going to walk around the room and look at all the posters and leave some notes, possibly sticky notes. You could also have them write it in their notebook about how this made them think differently about energy, matter, and climate. And so here's some sentence starters to help them think about these ideas. Really what we're doing is bringing that cross-cutting concept of energy and matter to the forefront of our thinking. So we're explicitly using that lens of energy and matter. We're also kind of thinking about, are we starting to think about climate differently? Then students are going to process their thinking from the posters and complete a data analysis handout. Now, this data analysis handout, you can see they're going to be thinking about possible causes, orbital changes, volcanic activity, solar activity, and carbon dioxide. And they're going to organize their thinking with this graphic organizer. Now, all of this is to lead to a building understandings discussion. And here's some key ideas that need to come out in that building understandings discussion. And basically, we're leading to the idea that carbon dioxide is most likely the cause of the increased temperatures, because if you look at the data, the carbon dioxide levels tracked with the temperature levels. And so we're going to come to this big idea through the building understandings discussion. And on their handout to prepare for that, there was also a question of an argument that they need to complete. So I think that blank is the likely cause of current temperature increase. So this was a scaffold to being able to participate in that building understandings discussion. Okay, once we've gotten to this point where we think it's carbon dioxide, we are going to introduce an energy flow model and some rules that we use as scientists to model energy inputs and outputs in a system. And so there is a poster that you're going to make that's going to have several different numbered rules on them. And this is going to be drawn on a chart paper as you, and the students are going to copy this into their notebook as you go over the rules. And so rule number 1 is objects are represented with a square. And so you can draw this square and it represents the sun. Ice is an object, so it has, it's represented with the square. So you're going to go through each rule and represent it using a very normal energy flow model. And then we're going to discuss how this model might change in different scenarios. So here's some different causes that we're going to model. The first one is, what if the Earth tilt was greater than it is now? What if there was a major volcanic eruption? What if the sun had greater activity? And what if there was more carbon dioxide? So thinking about those different possible causes of climate change, we're going to represent our thinking using the model rules that we just went over. And so you can see here are the 4 scenarios. We're showing that we can use all the rules, including like the boundaries of the system. We have what's inputting into the system with an arrow. We've got text to talk about what's happening. And you also want to think about that use of particles, that particle modeling. What's happening to the particles of air? What's happening to the particles of ice? So really trying to bring that chemistry lens back into our models. Okay, and so once we modify our models, we're going to represent our thinking in a progress tracker. And again, I've shared with people before that this can happen in 2 ways. At the beginning of a unit, it might be helpful to kind of model what it's like to put ideas in a progress tracker. You can do this under a dot cam. There is an answer key that you can help guide you to filling out the progress tracker as you ask students questions and they give you answers. You kind of fill it out together. That's a scaffold. Its intended use is that students will really consider what they figured out in pictures and words. It's a metacognitive thinking strategy where they really process the information and put it in their own words. That's the intent for this, and that's where you should push towards. But I will tell you, Unit 1, it's kind of hard to get students to do this. So consider maybe setting students up for success and kind of modeling how to do this, and then release the responsibility and let it do that more on their own as the unit progresses. So, okay, so that is the end of lesson 2. Let's go ahead and talk about how we're going to prep in the next video.